Hello everyone, welcome back. We're going to be doing next lesson in topic 8, which is law of sines. So it's a really special rule that we have in geometry when we're talking about triangles, and it helps us again relate our sides to our angles. So we're gonna use the law of sines today to solve problems. So first we need to talk about what is the law of sines, right? And then we have a couple new vocabulary. We've already talked about sine. And we've talked about inverse function a little bit, but not a lot yet. So we're gonna go and actually define that and talk about that now too. So go ahead and go to the end of the packet of your topic 8 packet, and let's look at our new vocabulary and the law of sines. Okay, so here we are on the terms page, and we're going to talk about inverse function. So the inverse function allows you to use the side ratio, right, of sine, cosine, or tangent to find the angle. So if I have a triangle, so let's just draw ourselves a right triangle here. And I'm going to label it ABC. And angle C is my 90-degree angle. Let's say I'm talking about angle A, and the side is, or the opposite side is 3, and the hypotenuse is 5. Right, because I have opposite of A and hypotenuse, that would be sine. And so I can say that sine of A is equal to 3 over 5. And we have looked at that already, right? Just writing the sine ratio. But what if I actually want to know what is the angle of angle A, right? Like, what is it? So that's when we take the sine inverse of both sides and it allows A to be by itself. So that gets rid of the sine here. And then we can take, oh gosh, that is not how you spell sine. Sorry. And then we can take the sine inverse of 3 over 5. And we did talk about this a little bit in 8-2. So this is just the notation. It's not an actual exponent. And it is on your calculator above the sine, cosine, and tangent buttons. So you would have to hit like second sine or second cosine or second tangent to get to the inverse. But then by entering this into your calculator, you would be able to find what the measure of angle A is. So using those inverse functions allows us to find a missing angle if we know the side, and we're able to write that trig ratio. Again, just as a reminder that trig ratios, so like sine of something equals, opposite over hypotenuse, those only work when we're talking about right triangles, okay? Okay, so let's scroll down now to our theorems and stuff. What happens if we don't have a right triangle? Right? Like how can I find missing sides and angles if I don't have a right triangle? And that's when we can use the law of sines and also the law of cosines, which we'll talk about in next lesson. Okay? So the law of sines is the ratio of the sine of an angle, so sine of C or whatever, to the opposite side is equal to the ratio of the angle to the opposite side. So what that means is, like if I take, I'm going to have to try to write small here, sine of an angle, let's just say angle A, and I know it's an angle because it's capital, over its side, so side A, right? Remember, angle is always capital, side is always lowercase, so this is sine of angle A over side A is equal to sine of angle B over side B. So angle B over side B. And that is also equal to sine of C over side C. So if you have an angle and the side across from the angle, you're probably going to be using law of sines. Now, even though we have all three of these written, like, right, 1 equals 1 equals 1, we typically only use two of them at a time, because if I only have two, then I can cross multiply and solve. But this is the law of sines, that I can write a ratio that the sine of an angle over the side across from that angle is equal to sine of an angle over the side across from the angle, and so on and so forth. So let's go back to 8.3 and let's look at how do we actually use the law of sines. Okay, so here we are back at 8.3. We're going to be kind of jumping around a little bit on this. But example 1 says, how can use the sine ratio to relate the length and angle measures in triangle ABC? Notice that triangle ABC is not a right triangle, so I cannot use trig ratios, but I can use the law of sines, which is that sine of an angle over the side across from the angle is equal to sine of an angle over the side across from the angle, which is equal to sine of an angle over the side across from the angle. We're not going to do this one. Okay, but again, typically we only use two of these, so you can use whatever combination you want, right? You can do A and B, or A and C, or B and C. It just depends on what the problem gives you. So the biggest clues, there's two of them, that you're going to use law of sines. The first clue is if you don't have a right triangle. If you don't have a right triangle, you can't use trig ratios, so you might use law of sines. The second clue is, do you know an angle and the side across from the angle? If you do, then you're going to be using law of sines. So let's look at example 2 where we actually use the law of sines to find side lengths. So here it says for triangle XYZ, what is YZ? So this guy, right? To the nearest tenth, so to the nearest one decimal place. So the first thing I see is, well, I don't know if this is a right triangle or not because I don't know this angle. So I'm going to find that angle, right? 180 minus 51 minus 77. So this is 52. Okay, so this is not a right triangle. So that's clue number 1. I'm going to use maybe law of sines. The second one is, do I know an angle and the side across from the angle? And I do right here, right? I know this angle and I know a side across from the angle. So that's my clue that I'm going to use law of sines. So how this works is I can say sine of my angle, and my angle that I know is 77, over the side across from the angle. Okay, so sine of the angle over the side across from it is equal to, now this is what I'm trying to find. So I want to use the angle that's across from it, right? These are the two pieces of information I want to use. So I'm going to use sine of my angle over the side across from it. And I don't know the side across from it, so that's just x. So here's my law of sines. Now I have a proportion, right? One ratio equals another ratio. So I just cross multiply. So x times sine of 77 is just x times sine of 77 equals, and then I cross multiply here and I get 7 times sine of 51. Well, I want this x by itself. So I'm going to divide both sides by sine of 77. Okay, so I kind of ran out of room, but we'll write it up here. X equals 7 times sine of 51 divided by sine of 77. And now this is something that I can enter into my calculator. So let's pull up our calculator and actually do that. Okay, so here's my calculator. Quick reminder that it needs to say degrees somewhere on your calculator. If you have a blue scientific calculator, it'll say degrees down here at the bottom of the screen. If you have a graphing calculator, it needs to say degrees up here. So I'm going to enter this whole thing in. Now, when I do it, I'm going to enter the top. So I'm going to do 7 times sine of 51, and I'm going to hit enter. And then I'm just going to hit divided by sine of 77, close parentheses. So I get like 5.58, but it wants me to round to the nearest tenth, so it'd be 5.6. So x is about 5.6, and I don't have units, so I'm just going to say units. Now, just to show you real quick too, you can enter the whole thing into the calculator if you're very careful. You would have to put this whole top part in parentheses. So I'm going to do parentheses 7 times sine of 51, close parentheses, divided by sine of 77. So notice I put the whole top in parentheses, and then I would get the same thing. You just have to be very, very careful with parentheses if you're going to enter it all in at the same time. Okay, I want you to find do this, try it. What is xz? So here is, this is y, right? What is xz to the nearest tenth? So I want you to try the same thing. My recommendation, right? Do I know an angle and a side across from the angle? Yes. So I would use this. And then do I know this angle across from the y? Yes. So set up a law of sines, cross multiply solve, give it a try. And when you're ready to go over it, hit play. Okay, so hopefully you tried it. If you haven't, hit pause, give it a try. We're going to set this up here. It's going to be sine of the angle I know, which is 77, over the side I know, which is 7, equals sine of the angle, right, that I'm using, which is 52. And the reason I have to use 52 is because that's what's across from the y. And the y is what I'm trying to solve for. So now here I have law of sines, and I can cross multiply. So I have y times sine of 77 equals 7 times sine of 52. And I want the y by itself, so I'm going to divide by sine of 77 and divide by sine of 77. And I get y is equal to 7 times sine of 52. My pen has a little lag in it today. Divided by sine of 77. And again, that's something that I can enter into my calculator. So let's go back. And I'm going to be very careful when I do this. I'm going to do 7 sine, or 7 times sine, either way, of 52. Close the whole top, then divided by sine of 77. And I get 5.66, right? And I want to round to the nearest tenth. So this 6 rounds this up to 7. So I get y is approximately 5.7 units. So hopefully you got that right. It's just a lot. It's just setting up the ratios, or setting up the proportion, cross multiplying. So let's continue to try these. We have one more, try it. So let's clear this and scroll down. One more try it here for you. You're given values, so make sure you plug in those values onto your image, and it wants you to find the measure, or sorry, the side length B. Okay, so again, pause the video, give it a shot, and then when you're ready to go over it, hit play, we'll look at it. All right, so let's go ahead and look at this. I know that angle B is 93 degrees. I don't know side B. I know angle A is 47, and I know side A is 7. So the question is it a right triangle? The answer is no. Then, do I know an angle and the side across from the angle? I know an angle and the side across from it, so I'm going to be using law of sines. Okay, so that tells me that sine of the angle I know, which is 47, over the side across from it, which is 7, equals sine of my other angle, which is 93, over the side across from it, which is B. And that's what I'm trying to find is B. So I cross multiply, right? So B times sine of 47 equals 7 times sine of 93. And I want to divide both sides by the sine of 47 because I want the B to be by itself. I'm running out of room. So I get B equals 7 times sine of 93 over sine of 47. So let's enter that into our calculator. So 7 times sine of 93, close the whole top, divided by sine of 47. And I get 9.558, and let's just keep rounding to the nearest tenth, which would be 9.6. Excuse me. So I get B is approximately 9.6. And again, I don't have units, so I'm just going to write units. Boom, voila. Literally, this is just all we're doing over and over and over again, right? Now let's look at doing the same thing, but what if it's the angle that we're trying to find instead of the side, right? So let's look at example 3 here where it's the angle. So here it says, what is the measure of angle R and angle S in this triangle? So the first thing, it's not a right triangle. Do I know an angle and the side across from the angle? And I do, right? I have 74 across from the 12.3. So I can use law of sines, okay? So sine of my angle, which is 74, divided by the side across from it, which is 12.3, equals, now I don't have the other angle, but I do know a side, right? So angle S is across from the side. So I can say sine of angle S over the side, which is 12.7. So I'm still doing sine of the angle over the side. It's just that now S is what I'm trying to solve for. So we're just going to do the same thing. Let's cross multiply. So 12.7 times sine of 74 equals 12.3 times sine of S. And I'm trying to get this S by itself, so let's divide by 12.3. I'm going to have to move it up here. I'm writing too big. So 12.7 times sine of 74 over 12.3 equals sine of s. So this is where I'm like, okay, I want to get this s by itself. I need to get rid of this sine. How do I do that, right? I can't just divide by sine. So this is when we use our sine inverse, where I take the sine inverse of both sides, and it ends up like canceling. I'll never get that same purple back, but that's okay. It ends up canceling out, so I get the sine inverse of all of this stuff, 12.7 times sine of 74 over 12.3 equals s. So the sine inverse, we're able to get that s by itself. Okay, and that's kind of the goal. That's what we want. And now this is something I can enter into my calculator. Now I'm going to show you the trick on doing it. Right, we know how to enter just this part, so we're going to do that first. I can bring up my calculator. There we go. Okay, so we're going to do the whole top is 12.7 times sine of 74. Here's the top, divided by 12.3. And I get some crazy number, right? Then I need to take the sine inverse. Remember, they're right above the sine, cosine, tangent, or the inverse. So I'm going to go second sine inverse, and then second, and then answer. And you have this on your scientific calculators too. But what that does is it allows you to take this number without rounding it and plug it in right there. And I hit enter, and I get 82.9887, right? All these numbers are quite big, so let's just round up to 83 degrees. So S is about 83 degrees. So this right here is 83. Sorry, the measure of angle S. So then to find the measure of angle R, I just subtract them all from 180. So then that tells me that the measure of angle R is not equal to, is approximately, is, 180 minus 83 minus 74, and I get about 23 degrees. And there are my values. So same idea, you set up the proportion, you cross multiply and solve. You just are using the inverse of your sine to get your angle. So I want you to try this one. I'll leave this guy up. What is the measure of angle N? So same idea. And then what is the measure of angle O? So pretty much identical to example 3, just different variables and different numbers. So go ahead and give it a shot. And then when you're ready to go over it, hit play. Okay, so let's look. I know an angle and the side across from the angle. I'm actually going to scroll up here so we can see a little bit better. There we go. Okay, so I know an angle and the side across from the angle, so I'm going to set up my law of sines. So sine of the angle I know, which is 70, over the side I know, which is 4, equals, and then the side I know here is 2, so the angle I have to use with 2 is n. So I'm going to do sine of angle n over 2. And we just cross multiply. So 4, I'm going to do it this way, sine of 40, 4 sine of n equals 2 times sine of 70. Right, and then we can divide by 4, divide by 4. I get sine of n is equal to 2 sine of 70 over 4. And then I want the n by itself, right? So I need to take the sine inverse. So n is going to be the sine inverse of this whole thing, 2 times sine of 70 over 4. And so when we enter this into our calculator, we should get that n is about 28 degrees. Okay, so this is about 28. Which means then the O should be really easy to find, right? I'm sorry, the measure of angle. Why am I forgetting that today? The measure of angle O then should be pretty easy to find because I just can subtract 180 minus 70 minus 28, and I get about 82 degrees. And that's it. One more try it here for you guys. So I'm going to scroll up. So again, pause the video at any point if you need. I'm going to scroll up here. One more try it. Fill in the values you know, and it wants you to find what is the measure of angle C. So pause the video, try it, and then we'll go over it here in a second. Okay, so hopefully you've paused the video and you've tried it. I'm going to fill in the values I know. I know A is 47. I know side A is 28. And I know side C is 26. And I want to find angle C. Okay, so do I know an angle and the side across from the angle? And I do, right? 48 and 28, or 47, 28. So I can do that. Sine of my angle. The angle always goes inside the trig, the trig ratio, or the trig function. Over the side across from it is equal to sine of angle C, which I don't know, over side C, which is 26. So same thing we just did. I'm going to cross multiply 28 times sine of C equals 26 times sine of 47. Divide both sides by 28. And I get sine of C is equal to 26 times sine of 47 over 28. Now I want that C by itself, so I need to take the sine inverse. So C is going to be equal to the sine inverse of 26 times sine of 47 over 28. And so you enter that into your calculator. No, you cannot use your phone. And I get that the measure of angle C is about, check your work here, 42.7 degrees. If you rounded differently, that's fine. That looks like a really weird 2. Let me try that again. 42, there we go, 7 degrees. So again, if you rounded differently or whatnot, that's fine. You did 43 degrees or whatever. But just knowing that you can't do this stuff on your phone. You cannot use your phone as a calculator for this stuff. You have to have either a graphing calculator or a scientific calculator or some sort of calculator that has sine, cosine, and tangent on it. But that's it. Not so bad. The only other thing that we have, guys, is example 4, and a try it, which is a word problem. So let's look at that and see how is this stuff used in the real world. Okay, so let's look at this example. It says the map shows the path a pilot flew between Omaha and Chicago in order to avoid a thunderstorm. So here's the storm, and so they had to go around the storm. How much longer is this route than the direct route to Chicago? So the direct route, if that storm wasn't there, would be 471 miles. But since the storm was there, they had to go around. So we want to know how much longer is it. So this is not a right triangle. And the question is, I need to know, right? Like this length, we can call this X. And I need to know this length, which is Y. Let's call it Y. Okay. because then I can add them together and figure out what the length is. So I know an angle at the turning point is 113, and I know the side across from it is 471. So I'm going to set up law of sines. So I can say that sine of my angle, which is 113, over the side, which is 471, equals, now the only other angle I know is this guy at Chicago, right? So that's going to be sine of my angle over the side across from it, which we labeled x. Okay, so we're just going to cross multiply and solve. So x times sine of 113 equals 471 times sine of 22. Divide both sides by sine of 113. Trying to write small so I can fit it. So I get x is equal to 471 times sine of 22 divided by sine of 113. And I can enter that into my calculator, and I get about 191.7 miles. So that tells me I can erase this, and I can write in 191.7 miles. Okay, great. So now I need to figure out what y is. Well, would have to know the angle here, and I can find the angle because the three angles of a triangle add to 180. So if I do 180 minus 113 minus 22, I get that this is 45 degrees. So now I can do the same thing. So I'm going to do sine of the angle I was given, which is 113, over, not sine, excuse me, over that 471. The reason I don't really want to use the sine of 22 and the 191.7 is because what if I calculated this 191.7 wrong? Then I would be calculating, the value of y incorrectly just because my numbers were wrong. So I always like to use what the problem gives me. And then I have sine of my angle, which is 45, over the side I'm trying to find, which is y. And I'm just going to do the exact same thing. I'm going to cross multiply. So y times sine of 113 equals 471 times sine of 45. Divide both sides by 113. So I'm going to skip down here. So I have y equals 471 times sine of 45, and then I divided it by sine of 113. Just like that. I enter this into my calculator, and I get that y is about 361.8 miles. So I can erase my y now, and I can write in that it's 361.8 miles. Okay, so I want to know then the total distance traveled, because the question is asking me how much longer is this route than the original. So the total here, the total distance from Chicago to the turning point to Omaha, there we go, is 191.7 plus 361.8, which is 553.5 miles. So the total distance, right, is 553.5. And the question is saying how much longer is that than just going the direct route? So I can just subtract, right? 553.5 minus 471. And so we can say the detour is 82.5. So 553.5 minus 471 is 82.5 miles longer than the direct route. Right? So to avoid the storm, we have to go an extra 82.5 miles in order to avoid that storm, which is necessary because we can't drive through or drive. We can't fly through a storm. So it is necessary to do that detour. It's just important to know how much longer it is so that the pilot can make sure that there's enough fuel and things and make sure that it's a safe trip. So okay, you guys have one, try it, and then we're done. It's the exact same thing. So even if you want to go back and pause the video on the last one so you can look at it, okay, it's the exact same thing. Here's just a different option. So on the way back, that storm is still there, but now the pilot decides to go north instead of south. And so this is the path he's able to take or she's able to take. And so now it's saying how much further um, is this route versus the direct route. So go ahead and pause the video, and then when you're ready to go over it, hit play. Okay, so here the pilot chose to go north, so he or she, is making a longer trip, but how much longer is it? I already know that from Omaha to the turning point is 260 miles. So I really just need to know this right here. I do know an angle and the side across from the angle, so I can use law of sines. So sine of my angle that I know, which is 148, over the side that across from it, which is 471 still, equals, and then the angle across from x is 15. So I can say sine of 15 over the side across from it, which is x. We just do our cross multiplication, right? So x times sine of 148 equals 471 times sine of 15. Divide both sides by sine of 148, and I get x equals 471 times sine of 15 divided by sine of 148. Once I have that, I can enter it into my calculator, and I get that x is about 230 miles. So this right here, I can get rid of my x, and I can plug in this about 230 miles. So the total distance traveled on this detour is 260 plus 230, which is 490 miles. So this detour is not as far, right? So 490 minus 471 is 19. So the detour to the north, right? If we go north instead of south, is only 19 miles longer than the direct route. So it's actually faster to go north of the storm than it is to go south of the storm because it's only 19 miles longer instead of 82 miles longer. All right, guys, nice job. Hopefully we're feeling good about law of sines, right? Just cross, multiply, solve. If you have any questions, let me know. We're going to do law of cosines in the next lesson, so we'll see you then.